The final complication present in some optimization questions is when two vertices tie for a maximum or a minimum value after using the optimizing function. When two vertices tie for the optimal value, they're both solutions to the scenario. In addition, all the points on the line connecting the two tied vertices are also optimal solutions. Let's take a closer look at this. So here's an example. Students at Film and Write are selling scented candles as a fundraiser for their annual trip. They're selling lavender scented candles and vanilla scented candles. They sell at most 10 candles per day. They sell at least 3 lavender scented candles each day, and they sell at least 2 vanilla scented candles each day. The profit for the lavender scented candles is $3, and the profit for the vanilla scented candles is also $3. What is the maximum profit the students make each day, and what are all the possible combinations of the scents to maximize that value? The process is the same as we always do. We start off defining the variables, so we let X be the number of lavender scented candles sold each day, and then we let Y be the number of vanilla scented candles sold each day. Now we need to translate all of the words into inequalities and then rearrange the inequalities into the Y equals AX plus B form. The first constraint says they sell at most 10 candles each day, so the total number of candles is X plus Y, and that has to be less than or equal to 10, so they can't go over that. Then we rearrange that into the Y equals AX plus B format, so we've subtracted X from the left side to get it on the right side, and we have Y less than or equal to negative X plus 10. They sell at least 3 lavender scented candles each day, so that's X is the number of lavender scented. They have to be greater than or equal to 3. They sell at least 2 vanilla scented candles each day, so Y is vanilla scented. It's going to be greater than or equal to 2. And as always, we have our two axes, X and Y. So the Y-axis is X greater than or equal to 0, and the X-axis, Y greater than or equal to 0. Let's take a look at the graph. So the green line is the X plus Y less than or equal to 10, or after we've rearranged it, Y less than or equal to negative X plus 10. The red line is Y greater than or equal to 2. The purple line is X greater than 3, greater than or equal to 3, sorry. And then we've, of course, got our X and Y axes, so we know we have to be above those. Above that one and to the right of that, because we can't have negative numbers in this situation. So now let's look at the shading for each of the others, because we've got less than or equal to, that says we're below that line, below the green line. The red line, it tells us it's greater than or equal to, so we're above the red line. And the purple line, it's also greater than or equal to, so again, we're to the right where the numbers are larger, so it's greater than. So the shaded pink area is the area where all of the arrows overlap. Once we've identified the polygon of constraints, we need to label each of the vertices. So we've labeled the vertices A, B, and C. Now we can go ahead and try to find the X and Y coordinates of each of those using one of our methods. So we're going to find the vertex A first of all. Vertex A is the intersection of two lines, Y less than or equal to negative X plus 10 and X greater than or equal to 3. So we convert that to equations so that we're working with an equal sign rather than the inequalities. And in this case, since we've got X equal to 0, we're going to simply take that 3 value and substitute it in. So we've got Y equal to negative 3 plus 10, so Y is equal to 7. With the X at 3 and Y is 7, that gives us vertex A is 3, 7. Vertex B, the two lines that go through vertex B are Y less than or equal to negative X plus 10 and Y greater than or equal to 2. We again change them into equalities and then use substitution to solve. We take our 2, and this time because it's Y equals, don't get caught there, Y equals, we substitute that in for Y. So this time we've got 2 equal to negative X plus 10, and we solve for X. Once we've got X equal to 8, we've got Y equal to 2. That gives us vertex B. Vertex C, two lines Y greater than or equal to 2 and X greater than or equal to 3. If we put them into equal signs, we change them to equalities, and that simply gives us 3, 2 as the coordinates of the vertex C. Now we need to go back and ask ourselves what was the question we're being asked. So we need the target objective. And if we look at it again, it says what is the maximum profit the students make each day and what are all the possible combinations of scents to maximize the value. So our target objective in this case is to maximize profit. So it's a maximizing problem. Now we create our optimizing function based on the information that we're given. We were told that for each candle that's sold, whether it's lavender or vanilla scented, regardless of the scent, they make $3 of profit. So we multiply each of those by 3, and that gives us our profit function. Now we take that optimizing function for profit, and we test it with each vertex. So we take the 3, plug it in for X, the 7, plug it in for Y, and calculate the profit. We repeat the process for vertex B and vertex C, and in this circumstance now, when we go to choose the maximum, we notice that we've got 30 for 2 of the vertices. So the question was asking us for maximum profit, which in this case is $30, and it happens at 2 vertices. Since those 2 vertices are along the same line, we also know that any other whole points along that line will give us the same optimal solution. So if we look at the graph here, you can see that it looks like the points here, 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 and here all give us points along that line. They all are where there are lines intersecting in the graph. So we've got vertex A, which was 3, 7. We move over, we're at 4, 6. Move over 1, we're at 5, 5. 6, 4. 7, 3. And 8, 2, which was the B vertex. So all of those are also solutions. So finally, to answer the question that was posed in the initial problem, the maximum profit the students can make is $30 per day, and they can make that by selling any of the following combinations of candles. And we show the table, so they can have 3 lavender, 7 vanilla, 4 lavender, 6 vanilla, and so on through the table. And again, if you look at it closely on the graph, that's all of the points along the line that are on whole numbers for both X and Y. Try the next question on your own, then come back to watch the video segment to check your answer and watch the solution.